Welcome back. We're going to work another example here using the quotient rule to find the derivatives of the functions. So we have our function here, k of x equals negative x squared plus 6x divided by 4x cubed plus 3. Now I have already written the quotient rule down here right below. V times the derivative of u, and we're going to subtract from that u times the derivative of v, and we're going to divide that by v squared. So we need to first start off by labeling our parts here. So our numerator here is going to be u, and our denominator is going to be v. And we need to find the derivative of both here. So the derivative of u is going to be found by taking my exponent here of x squared, and we need to separate that negative 1, so negative 1 times 2 times x to the power of 2 minus 1. Again, just using my power rule here. And we also have an x here. This is to the first power, so we have plus 6 times 1 times x to the 1 minus 1 power. Again, using the power rule. We're going to simplify this, so we have negative 1 times 2. So this comes out to negative 2x, and that'll be to the first power, plus 6 times 1, and then we have x to the 0 power here, which means this will be a constant, or this will be 6. So the derivative of u here is negative 2x plus 6. The derivative of v, on the other hand, we have 4 times x cubed plus 3. So 4 times, again, bring that exponent over, 3 times x to the power of 3 minus 1. And we do not need to include this plus 3 because the derivative of a constant is always 0. So we just need to simplify this. So we have 4 times 3, which is 12. And then x to the 3 minus 1 will be x squared. Alright, so now let's plug in our values here into our quotient rule. So v was 4x cubed plus 3. And we're going to multiply that by the derivative of u, which was negative 2x plus 6. And we're going to subtract from that, starting with u, which is negative x squared plus 6x, and the derivative of v, which is 12x squared. And we're going to put that over v squared, which will be 4x plus 3, 4x cubed plus 3 squared. Okay, so before we can subtract these two amounts, we need to use FOIL down here at this end to distribute this out, and then also we need to distribute this 12x squared into this first set of parentheses here. Okay, so just using FOIL or the box method here, whichever you're more comfortable with here. Let's go ahead and factor this out. So we will get negative 8x to the 4th plus 24x cubed minus 6x plus 18. And again, that's just using FOIL. And again, if you're more comfortable with the box method, please feel free to use that. Minus, we're going to distribute here the 12x squared into both parts here. So we will get negative 12 times x to the 4th plus 72x cubed. And we're going to put that all over 4x cubed plus 3 squared. Now let me move this up just a little bit here. Now we're going to take our last statement here and go ahead and subtract the two quantities here. So we see we have negative 8x to the 4th, and we're going to subtract negative 12x to the 4th. That will give us 4 times x to the 4th. Be careful about subtracting by a negative number here. Okay, and so we notice this is cubed and this is also cubed. So we have 24x cubed minus 72x cubed. So if you want to distribute this negative 1 in here, to go ahead and move that around, because that'll change the sign here and also change the sign here, go right ahead. Okay, but if you're comfortable with subtracting by integers, negative and positive, then you'll do just fine. But if you want to distribute this in here, go right ahead. That'll give us negative 48 x cubed, and then the rest of it will just come on down, minus 6x plus 18 over 4x cubed plus 3 squared. Well, at this point we don't have anything left to simplify, so this will be our answer. Our original function was k, so this is the derivative of k of x.